What is a radian? And so you've got that activity in the book where you're working with the fuzzy stick and coming up with how many times the radius goes around the circle. And what we're talking about circumference is we take 2 times pi times the radius, or pi times the diameter, to get the circumference. R stands for radius, D stands for diameter. And when we work with a unit circle, a circle with center at the origin and a radius of 1 unit, that's the definition of a unit circle. We find out that radius goes around 6 and a little bit more times around the circle. That little bit more is pi, is what we've got. So twice times the radius times pi gets us all the way around the circle. Now at the bottom you've got that pop-up that we've got. So on the cover you're going to call on one side converting radians to degrees, on the right side converting degrees to radians, and then underneath, to convert from radians to degrees, multiply the number of radians by 180 degrees divided by pi radians. To convert degrees to radians, multiply the number of degrees by pi radians over 180 degrees. Now I've got a couple examples here. In the notes there are a couple more. In the other video there are a couple more. I'm just going to walk through these. So 3 pi 11ths radians to degrees, well 3 pi radians over 11 times 180 degrees over pi radians. The pi and the radians cancel, and we get 3 times 180 is 540 over 11. That's the exact answer, and approximating, that's about 49.09 degrees when we divide it. Taking negative 120 degrees to radians, we take that times pi radians over 180, so that gets us negative 120 times pi over 180. That simplifies to negative 12 over 18, which is negative 2 pi over 3 radians. Sketching angles in standard position. If an angle is in standard position if its vertex is located at the origin and one ray is on the positive x-axis, which there we go is our initial side, and we just rotate around that to get our terminal side of our angle. Going counterclockwise, we get positive angles. Going clockwise, we get negative angles. Reference angles. A reference angle is formed by dropping a perpendicular from the terminal side of a standard position angle to the x-axis. That works with the bow tie method. So if I was up here on, the left, we would just measure the angle down to the x-axis. It's always to the x-axis, and it's always a positive measure for the reference angle. Coterminal angles, if two angles in standard position have the same terminal side, they are called coterminal. Unit conversion, we've got quite a bit of information here. Units of length, units of time, units of volume or capacity, and units of mass. That's in standard up at the top, and in the bottom we've got metric. Units of angles, we have pi radians is 180 degrees. We also have angular to linear. Angular is how many revolutions you have, gives you circumference. One revolution, 2 pi radians would be 1 circumference around the circle. Arc length, we can take arc length as 2 pi r, so the circumference of the circle, times the fraction that we have, so times the central angle divided by 360. Area of a sector, well, area of a circle is pi r squared, and we just take that times the central angle divided by 360, just times the fraction of the circle that we're trying to find. Now some practice with it. Examples, convert 500 meters per second to miles per hour. We start with 500 meters over 1 second, and we want to get rid of the meters, so there are 100 centimeters in 1 meter. This way the meters cancel. That's a unit conversion. There are 2.54 centimeters in 1 inch, and so that cancels the centimeters. And then we have 1 foot is 12 inches. That'll cancel inches. We've got it down to feet per second. Then there are 5,280 feet in a mile, so now we cancel feet. So now I've got miles per second. That means I need to get rid of the seconds, and since seconds is on the bottom, I will have seconds on top for the unit conversion. 60 seconds is 1 minute. 60 minutes is 1 hour. Now we multiply all the tops, multiply all the bottoms, and then divide. Gets us 1,118.47 miles per hour. Holy crap, that's going fast. convert 1,000 feet to kilometers. Well, we start with 1,000 feet, and feet I can turn into inches. There are 12 inches for every foot. There are 2.54 centimeters per inch, and so that's got us down to centimeters. To get rid of centimeters into meters, there are 100 centimeters in a meter, and then there are 1,000 meters in a kilometer. Feet, inches, centimeters, meters all cancel. 1,000 times 12, well actually I can cancel the 2,000s. So it's 12 times 2.54 divided by 100 gives us 0.3048 kilometers. Next couple, converting degrees to radians or radians to degrees and then finding coterminal angles. So we start with 320 degrees times pi radians over 180 degrees. That gets us 32 pi over 18, and that simplifies to 16 pi over 9 radians. 320 degrees happens to be in the fourth quadrant. And if I want to get a negative coterminal, well, or a positive coterminal, I just take 16 pi over 9 plus 2 pi. Well, 2 pi would be 18/9 pi, so 16 plus 18 happens to be 34 pi over 9 radians. To get the negative coterminal, we just take our angle minus 2 pi, and that gets us negative 2 pi over 9 radians. Convert 5 pi over 3 radians to degrees. So 5 pi over 3 times 180 over pi. That gets us, the pi's cancel, 3 goes into 80, 180 60 times. 5 times 60 is 300. And 300 happens to be in the fourth quadrant also. Coterminal, 300 plus 360 is 660. 300 minus 360 is negative 60. Convert 54 degrees, 45 minutes, and 20 seconds to degrees. Well, we'll come back to that one. Convert 15 revolutions per minute to radians per second. Oh, there it is. So 54 degrees over 1 plus 45 over 60, because there are 60 minutes in a degree, and then there are 60 times 60 seconds in a degree. And so 54 plus 45 over 60 plus 20 over 3600 is about 54.7556 degrees. Convert 15 revolutions per minute to radians per second, so I have 15 revolutions. There are 2 pi radians in 1 revolution. This gets us our radians. And then per second, we've got it per minute, so get rid of the minutes. There are 60 seconds. Multiply the tops. 15 times 2 is 30. Times pi, 30 pi over 60, that gets us pi over 2 radians per second. Arc length is the circumference of the circle times the angle divided by 360. So ours is 2 pi times 10 times 140 over 360, and that simplifies to 70 pi over 4 inches, or 24.43 inches. Asking the question a different way, we've got the radius and we've got the length. What is the angle? And so we have 150 pi equals 2 pi times 80 times theta. Theta happens just to be how many radians it happens to be. And 150 pi divided by 160, that gets us 15 over 16 radians, which is about 53.71 degrees. Find the area formed by a central angle of 135 degrees and a radius of 75 feet. So pi times radius squared times angle divided by 360. So that's going to be pi times 75 squared times 135 over 360. That simplifies to 6,626.80 feet squared. Find the area formed by a central angle of theta being 2 pi over 3 radians and a radius of 2.5. So plug in what we've got, pi times 2.5 squared times 2 pi over 3 radians divided by 2 pi. That gets us 6.54 feet squared. Now here you've got some practice with that, and then the next page we're looking at for you guys to come up with using Pythagorean theorem the measures. So on that first one that we've got up here at the top, it's a square. They're all squares. So C would be 90 degrees. A and B are half. Those are going to be, so cutting 90 degrees in half, because that's what a diagonal does, those are both going to be 45. So all of these are the same picture, so we can fill in all the angles, okay? And then we've got the side across from angle A is 1, the side across from angle B is 1. Now use Pythagorean theorem to find C, and use that to find all of them, and then see if you start noticing a pattern. Make sure you simplify any radicals. And then we're going to do the same thing with equilateral triangles. And so we can take a look at this one up here. And so taking a look, equilateral triangle also means equiangular. So since all the angles of a triangle add up to 60, or 180, that divided by 3 is 60. So angle B happens to be 60. That's a horrid way to write it. Our angle C is that 90. Okay, and then the altitude right here cuts the 60 degrees in half, so that's 30. That's a 30, 60, 90 triangle. All the triangles are the same, so you can fill that in. And oh, hey, look, we can look at them at the bottom. And then we've got the long side is 2. Okay. How much of this bottom side across from A? Well, that's cut in half, so that's 1. Now see if you can find the missing side, and do that on all of these and recognize the pattern. Okay. When you get the pattern recognized, you're going to come over here on these two and summarize it on these. Okay. And then on the proof book, you're going to practice it, special right triangle practice. Up here on these, they're going to come from this and this, always. Angles on top and side measures on the bottom in the generic. Then underneath, you're going to write what the answer is. So like right here, you're going to write x equals what? X equals and y equals for all of those in the proof book, and then check it with me. Okay. And then we've got some practice here with more of it, working with special right triangles. And you're going to be able to find all of them except ND with what we've got right now. And you got to kind of jump into chapter 6 to get ND. And then the last one, working with 30, 60, 90, and 45, 45, 90, we've got the dragon puzzle problem. And so you're going to be writing all of your answers A through J up here, and then what those are squared down below. Remember to write them in simplified radical form, okay? And you'll be checking that answer with me as well.